Welcome all my dear students to Sudharma's physics classroom. Today we are going to discuss the topic house electrification from class 10 physics. So we are almost at the end of the chapter magnetic effect of electric current and electromagnetic induction. So if you are watching this class for the first time, you have a lot of other videos from the same chapter. So I'll be giving the link for those videos in the description box. Okay, so let's start today's topic. So what is house electrification? So before going into that topic of house electrification, let's see how from the generating station till it reaches to the consumer, how electric current is transmitted. So from the generating station, see, we have a lot of power generating stations like hydroelectric power stations, thermal power stations, nuclear power stations, etc. From there, when the power is generated till it is reaching to the consumer, what are the processes taking place? So in the power generating station, the electric current developed is produced is at 11 kilovolt. So this 11 kilovolt for the transmission purpose, it will be stepped up into 132 kilovolt. So 11 kilovolt to 132 kilovolt, because here for the transmission purpose in a grid substation, this voltage 11 kilovolt will be stepped up into 132 kilovolt. Why it is increasing the voltage? This is for the transmission of power. So why we have to increase the power? We have the equation P equals VI, right? So for a given power, for a constant power, voltage and current are inversely proportional. And we know that according to Joule's law of heating, when the current is more, then the heat generated will be more. So you might have seen the power supply lines, right? When we travel along highways, we see these power transmission lines. So it has to go a long distance. That means the conductor is very lengthy, right? The transmission lines are very lengthy. So it takes a lot of time. It has a lot of distance to travel, right? And even if when in that case, if the current is also more, then the heat generated is going to be more. So when the heat generated is more, lot of energy will be wasted in the form of heat. So to reduce that, to reduce the current, the voltage will be increased for the transmission purpose. And this 132 kilovolt, it is a very high voltage. We don't need that much high voltage. Understand, this is only for the transmission purpose. Then in the main substation, it will be stepped down to 33 kilovolt. So you know, some industries require a heavy voltage. So high voltage required industries, that will be this 33 kilovolt will be supplied to those heavy industries. And in an intermediate substation, the voltage is again stepped down to 11 kilovolt. So that will be given to light industries, which requires only less amount of voltage. Then we, the consumers, right, the common consumers, we need only 220 volt. In India, it is around 220 to 240 volt. So the voltage coming to our house, right, it will be stepped down to 220 volt and it will be given to the consumer. So this happens in the city substation. So all these processes, right, you can see the voltage increased again, then decreased again, still it is decreased to 220 volt. That means from this 11 kilovolt, lot of processes happened. So all these are done with the help of transformers. Step down transformers and step up transformers do all this work. Okay, so this is a process how electric power is reaching to our house. And already we discussed in our house we are using alternating current, right? Now coming to the house connection. When we were discussing the advantages of series and parallel connection, we have already discussed our house electricity connection, house wirings are done in parallel connection, because parallel connection has a lot of advantages. Now, how it looks like inside the connection, right? How we are going to connect it? What are the procedures we have to follow while connecting the house wiring system? So mainly we have three types of wires. One is the live wire or the phase line, and the neutral wire, and the most important earth wire, earthing. Okay, So live wire will be connected to the main fuse, and even the color code is also important. Live wires are red in color, neutral wires are black in color, and earth wires are green in color. So the insulation covering given to all these wires are of different colors. That is important because during connection, right, when a person comes and rectifies our connection, he should know which one is live, neutral, and earth wire, because live wire carries the highest voltage of 220 to 240 volt, and neutral wire contains 0 volt. So if you just simply touch only the neutral wire, there is no problem, because we need neutral and live wire because we need a closed circuit for the current to flow. So 220 and 0, it creates a 220 volt potential difference. So remember, these wires are connected to the kilowatt hour meter. In the first chapter of current electricity, we have already discussed about kilowatt hour, what is kilowatt hour and what is this meter, right? So all these lines are connected to the kilowatt hour meter, and after that the live wire is connected to the fuse, main fuse. So this main fuse is given by the electricity company in our locality. Okay, and then it goes to the main switch. Almost all of you might have seen the main switch in your house, right? So remember, the live wire has to be connected to the fuse. We cannot connect the fuse wire to the neutral wire. It's not like we cannot connect, we can connect, but there is of no use if you connect the fuse wire to the neutral wire. So important thing, live wire has to be always connected to the fuse. Then it goes to the ELCB. I will be explaining what is this after some time. Okay, so this is again a safety device. Then after that, it goes to the main distribution board. What is distribution board? Inside our house, mostly in our living room, we can see a box which contains lot of switches, right? So those switches, they are the MCBs. MCBs are miniature circuit breakers. So all these are protective measures for our appliances. Then always understand here, you observe the connection here. This live wire is always connected to the fuse. This is the symbol for the fuse. Okay, then goes to individual appliances where the switches are connected. So this diagram is very, very, very important. So mainly the points are, we have 3 types of wires: live, neutral, and earth. Earth wire is also at 0 potential. And why earthing is required? You might have noticed the 3-pin plugs in our house, right? 3-pin sockets. So 3-pin sockets are always safe to use because it protects us from excess current flowing. If any metallic device is there, we are using any metallic device, by chance, by mistake, if you touch the external surface, if there is any excess flow of current, it just goes to the earth through the earth wire. That is why earthing is very, very important. Now observe the connection here. You see, the neutral wire shouldn't touch the live wire. Okay, if neutral and live comes in contact with each other, that creates short circuit, and that will be creating a very low resistance path for the current. High current flows through the circuit and excess heat will be generated. Sometimes it may cause fire also. So we have to make sure the neutral wire is not touching the live wire. Very, very important. Okay, so you have seen this jumping already in the circuit symbols. We have seen that. Still, let's see what is the difference between that connections, right? So when they are crossing, when they are just connected, we have to just meet them at one place. If they are not meeting at one place, we have to just jump from there, right? You can see the jumping from there. So this kilowatt hour meter, kilowatt hour is the commercial unit of energy, and this is how a digital kilowatt hour meter or a watt hour meter looks like. So this is from where our the person from the electricity board comes and takes the reading of that particular month, and it comes as the electricity bill. So commercial unit of energy is kilowatt hour. So commercial unit of electrical energy is kilowatt hour. A device of power 1000 watt when used for 1 hour consumes 1 unit of electrical energy. So 1 unit of electrical energy means it is the commercial unit of energy or kilowatt hour. So in those connections, you might have already seen the fuse wire, MCBs, ELCBs, etc. So for what purpose we are using all these devices? Fuse wire is a protective device. It works on heating effect of electric current. So this fuse wire is made of an alloy of tin and lead. It is called a solder. So it has some specialities. It will have high resistance and a very low melting point. Fuse wires are of different current rating. In the first chapter already we have discussed the current rating of the fuse wire or the amperage of the fuse wires, right? So when excess current flows through the circuit, the fuse wire will melt and it will protect the device. So the problem with this kind of fuse wires is if we want to replace it, we need to get another fuse wire of the same current rating. Right? It is not very easy to get that at a particular moment, right? So, and it takes some time to change this fuse wire also. So nowadays in all our houses we can see this miniature circuit breakers. This is what we see in our distribution box within our house. So here let me just show you that distribution box here. See the MCB distribution board, right? Within that you can see many switches. They are the miniature circuit breakers. So nowadays when wiring is done, different rooms will have different connections, and remember it's always in parallel connection. But still, if something happens to one of the rooms, then other rooms connections will not be affected, because the connections nowadays it is done like that, and it is very convenient. And there are two types of circuits like power circuit and lighting circuit. So all these will have different current rating fuse wires or different current rating MCBs. Another type of protective devices, earth leakage circuit breakers or ELCBs, and RCCBs, residual current circuit breakers. But the most common one and the most convenient one is miniature circuit breakers. So remember, when excess current flows through the circuit, these safety elements will be safety devices will be breaking the circuit, right? And all these you can see the term circuit breakers. They break the circuit, and when the circuit is broken, then it will protect the circuit, right? So there will not be any fire or any unwanted incident will not take place if these devices are connected to the electrical connections. Okay, so they are the protective measures for our household system. And the 3-pin plug points I was talking about, the earth connection, right? As I told, we have three types of connection, 3 wires, live, neutral and earth wire. Why we need earth wire, and what kind of devices will be using this earth wire? This green color wire that shows the earth wire, and you can see this is the part of, this is an electric iron, and the third pin that is the earth wire. So the in a plug point you can see the bigger one, right? That is the earth wire, earth connection. So earth connection is earth wire in a plug point that is longer and thicker, because it may ensures that once we insert the plug into the socket, the earth wire is connected first, then live and neutral. So it ensures the safety of the person who is using that device. So why we need this, especially where we connect all the devices, we will not use the 3-pin plugs, right? So why we need these 3-pin plug points, especially those devices which has high current rating and those which has metallic parts, right? So this third wire, the earth wire, will be connected to the metallic part of the device. Okay, so 3-pin plugs are very safe to use. Otherwise, see 2-pin plug points, it is okay, but especially if it is a high current rating device, make sure you are using a 3-pin plug. So where these 3-pin plug points, 3 pins are connected, so the metallic part is connected to the earth wire. Live and neutral, there will be separate connections. Okay, so that's about house electrification, and here we are finishing the chapter today. The explanation of the content is done. So read the textbook. If you have any doubt, you can put that in the comment box. So in the coming video, we will be discussing the text back questions and answers, and lot of extra questions I'll be giving there so that you score very good in the coming exams. Hope all of you have understood the concept, and there are many portions cut from this part because of the pandemic. They are reducing the syllabus. That doesn't mean you need not study it. You have to study it because for higher studies, definitely you all need these concepts. Okay, so make sure you are reading the textbook properly and learning the concepts very clearly, no matter the syllabus is reduced or not. That is what I would like to say. So we'll see you soon with the text back exercises, text back questions and answer discussion in the next video. So if you are watching this video for the first time, please subscribe to the channel and click the bell icon for more updates. Thank you for watching and bye.